In this final video for Chapter 10, we're going to talk about the different types of chemical reactions that we typically deal with. The first one that we want to talk about is a simple combustion reaction. This happens all over the place. We deal with it in our vehicles, our cars, motorcycles, whatever. We deal with it when we're talking about heating, power generation, and so on. We deal with combustion all the time. The basic idea is you have a fuel of some sort, which in most cases is a hydrocarbon, an atom that is made up of hydrogen and carbon. So, and then it reacts in the presence of oxygen, and then when they react, they produce carbon dioxide and water. In this example here, we have CH4, which is the chemical formula for methane, combined with oxygen, and it produces carbon dioxide and water. Pretty typical standard combustion reaction. There are many different types of hydrocarbons that can be used for fuel. Gasoline, propane, butane, even simple household items such as cornstarch and sugar can be used as a fuel. Here are some other alternative classifications. These are some of the more common ones that we deal with. One is called a combination reaction. That's where you take two atoms or two molecules and you combine them to form one larger molecule. That would be a combination reaction. A decomposition reaction would be the opposite, where you start off with one larger molecule and you end up with two smaller atoms or molecules. And basically you break the molecule apart. Third one is a replacement reaction, which would be you have a molecule plus an atom, and then one of the atoms in the molecule is replaced by the sole atom. So in this first example, Y is exchanged with Z. In other words, the negative part of the molecule is replaced. In the second example, X is replaced with A. In other words, the positive part of the molecule is replaced. Then the fourth alternative classification is the ion exchange reaction, where you have two compounds and the one part of each compound switches. They exchange ions with each other. And you can get a whole bunch of different results from these types of reactions, including solid precipitates. That means that something forms out of the solution and then drops out of the solution. You can create a gas that escapes the solution, or you could generate even water. Now, essential in all of these reactions is what we call the oxidation-reduction reaction. Basically, what happens here is you have a molecule which either gains or loses electrons so that it can react with other molecules. If a molecule or if an atom loses electrons, it's called oxidation. So if it loses electrons, it becomes positively charged. So that would be oxidation. Reduction would be where it gains electrons, so it becomes negatively charged. Easiest way to think of this is reduce. And when you gain electrons, you get a more negative charge. So you're dropping the charge to negative values. So reduction, you reduce the charge into the negative region. So here's a good example. You have Fe2O3, combine that with carbon. The iron, Fe, will exchange places with the carbon and become just plain iron and carbon dioxide. So this is a good simple oxidation reduction reaction because the iron has to gain electrons from the carbon, which loses the electrons. So carbon loses electrons, therefore carbon is the reducing agent and iron is the oxidation agent. And notice in this reaction, both the Fe2O3 is a solid and the carbon is a solid. The products, iron is also a solid, but then carbon dioxide is a gas. From this reaction, we produce a gas, which then evaporates from the substance and escapes into the atmosphere, or is trapped and harnessed, or whatever its use is for. So here's a good example of a combination reaction. Again, a combination reaction is where you take two atoms or two substances and they combine to form one larger compound. For example, if you take iron and combine it with oxygen, you get Fe2O3, also known as rust. This is the rusting process. This is what causes any form of steel to start to break down and form that brown, rusty stuff. A decomposition solution would be where you take one substance and break it down into two simpler substances. So you have this example, mercury monoxide, which breaks down into mercury and oxygen. There's another great example of this, where you take water and you break it down into hydrogen gas and oxygen gas. Now, oxygen gas, of course, has two oxygens, so we're going to need two water molecules to satisfy that. But now that we've done that, we have 4 hydrogen atoms, so we need to have 2 hydrogen gas molecules as well. So there's our balanced equation. This process is called hydrolysis. We use it all the time to break down water into hydrogen gas and oxygen gas, which can then actually be used and recombined later in the form of a battery. It produces electricity. Just an interesting little side note on that one. You don't have to remember hydrolysis specifically, but it's a good example of a decomposition reaction. Here's a replacement reaction where you have an atom you have one substance in which the negative part of that substance is replaced by some other atom. Here's an example in this figure showing a reaction between metallic aluminum and a copper chloride solution. Now, when you combine it, the aluminum replaces the copper in the solution, so the aluminum foil, metallic aluminum, essentially turns into copper. And it's not magic, it's just that the aluminum atoms leave and become part of the solution, and the copper becomes deposited onto the metal. And so you end up with a copper metal instead. Here's an ion exchange reaction example. In this example, you have 2 substances, but if you look here, you have AX plus BY. The reaction, you take the X and it exchanges with the Y, so you are left with AY plus BX. In our previous video, we looked at an example of having hard water, of having calcium bicarbonate and mixing it with sodium carbonate. And what we had there was an ion exchange reaction, which caused the result, which in the previous video was calcium bicarbonate, calcium bicarbonate, I believe it was. I have to go back and look. You can go back and look at the exact example there. But this became a solid and it precipitated out of the solution. So this is a good example of an ion exchange reaction with a solid precipitate product. Now, when we look at chemical reactions, the way we indicate a solid precipitate is we have a down arrow, which indicates it falls out of the solution. You can have a gas, in which case we have an up arrow, which indicates it turns into a gas and evaporates from the substance. Or you have water, which we often indicate with AQ, aqueous. And those are a number of different types of chemical reactions we typically deal with.